Good day everyone, I'm Ferrand Noche, a computer scientist from the University of the Philippines, Manila. Today I'm excited to present my project, GabAI, short for Grad-Aided Bioscan Intelligence. This mobile application was developed as a part of a undergraduate thesis or special program titled Transfer Learning and Optimization Strategies for Lightweight CNNs in Mobile-Based Monkeypox Lesion Detection with Explainable AI. So why did I create this project? Monkeypox is a zoonotic disease that has spread globally and was declared a public health emergency in 2022. In recent years, the Philippines has reported a growing number of suspected and confirmed cases. However, diagnosing monkeypox remains a challenge. It is visually resembles diseases like chickenpox and measles, and while PCR testing is the gold standard, it is expensive, time-consuming, and not always accessible, especially in underserved communities. This presents an opportunity. Artificial intelligence and convolutional neural networks can provide fast image-based skin lesion detection, but most AI systems lack transparency. To address both accessibility and explainability, I developed a mobile diagnostic tool empowered by Explainable AI. Here are the key challenges and how I address them. So first, not all smartphones can run complex deep learning models. So I use lightweight CNNs, specifically MobileNet V2 versus EfficientNet V0, which are optimized for mobile devices. Second, there is a lack of annotated monkeypox skin lesion datasets. So I applied transfer learning and tested several optimization strategies to improve model performance despite limited data. And lastly, clinicians often distrust AI due to its black box nature. So I integrated explainable AI tools such as GradCam or Lime to make the model's predictions more transparent and interpretable. The first dataset used is the monkeypox skin image dataset. So it was developed by Dipon Karbala and MD Shahim Hossein from the Islamic University in Bangladesh and the University of Science and Technology of China. The second dataset is the Monkeypox Skin Lesion Dataset version 2.0 or MSLD B2.0. This dataset expands lesion diversity and includes more skin tone variations. It was iteratively developed from June 2022 to May 2023. So this system explores multiple configurations. First, in transfer learning, we have feature extractions, which is freezing the base model versus fine-tuning, which is unfreezing the selected layers. For optimizers, we have ADAM versus SGD. For learning rates, we have 0.001 versus 0.0001. For imbalance handling, we have none, class weights, oversampling, and both. And for the explainable AI, we have GradCam versus Lime. For the parameters of the pre-trained models, we will be using the default parameters. Here's an overview of the end-to-end workflow. So first, we have the pre-processing, which combine both datasets, normalizing pixel values, and applied stratified data splitting. For imbalance handling, we have the 4 approaches. And for the augmentation, we applied rescaling, rotation, shifting, zooming, flipping, and brightness changes to boost generalization. For the transfer learning techniques, we have feature extraction and fine-tuning. And for the pre-trained models, we have MobileNet V2 and EfficientNet V0. For optimizers, we'll be choosing ADAM or SGD. And for the learning rates, we will be comparing 0.001 and 0.0001. For the evaluation metrics, AUPRC and accuracy are our primary metrics. AUPRC was chosen as the primary metric due to its robustness on imbalanced dataset, especially for underrepresented classes like monkeypox. And for accuracy, it served as the secondary metric, providing a general view of performance. For the explainable AI, we will be comparing GradCam and Lime. Then for the app integration, for the front end, we will be using React Native, and for the back end, I will be using Flask. There are no database, so user data is not stored, prioritizing privacy and security in compliance with ethical AI standards. So this figure represents the AUPRC scores across different model configuration. Feature extraction consistently yielded higher AUPRC values than fine-tuning, while class weights provided only slight improvements, while oversampling sometimes lowered AUPRC, particularly during feature extraction. MobileNet V2 outperformed EfficientNet V0 across the board. ADAM worked best during feature extraction, whereas SGD delivered more consistent results overall. And for learning rate, 0.001 performed better for feature extraction, while 0.0001 was better during fine-tuning. Here are the accuracy of the models. For feature extraction, again performed better than fine-tuning, and class weights had minimal impact, while oversampling generally reduced accuracy. MobileNet B2 led across all configuration. Adam showed higher accuracy in feature extraction, while SUD was consistent across both strategies. Then learning rate of 0.001 was more effective in feature extraction, while 0.0001 was optimal for fine-tuning. So here are the summary of accuracy and AUPRC. And for our top model, the top configuration has imbalanced handling of class weights, transfer learning, feature extraction. For the CNN is MobileNet B2. For optimizer, Adam, learning rate of 0.001, so it yielded to AUPRC of 92.84 and accuracy of 85%. So this setup gave the most reliable and interpretable results for monkeypox lesion classification. So to enhance clinical trust, two XAI techniques were used, Grad-Cam and Lime. So Grad-Cam produces a heat map that highlights relevant lesion areas using smooth color gradients. It's intuitive, visually clear, and aligns well with the clinical markers like inflammation. Lime segments the image into superpixels and assigns importance scores. While it offers a granular view, it is slower and harder to interpret. In performance tests, Grad-Cam generated results in just 0.3 seconds, while Lime took over 11 seconds. With its clarity and speed, Grad-Cam is the better choice for real-time clinical use. So the mobile app has two main sections, which is the Home and Explore tab. In Home tab, they can upload an image or take one with the camera, then view the predicted class and confidence score, then see the Grad-Cam heat map for visual explanation, and save results as a PDF including the outputs. And a disclaimer clarifies that this tool is for decision support and not a substitute for medical advice. The Explore tab focuses on educational and transparency. It includes a guide on how to use the app step by step, a legend for interpreting the Grad-Cam heat maps, an explanation of a legend for interpreting Grad-Cam heat maps, a section about the developer and the project goals, and another disclaimer to manage expectations. Now that we have explored the system's inner workings and user interface, let me show you GabAI in action through a live demonstration. So here is the home tab of GabAI. So first we try using the camera. Then submit it for prediction. So it shows here that the result is negative and the prediction is normal. Then here is the save button to save the video out this one. Then submit for prediction. So this one shows a positive result. So the prediction is monkeypox with a confidence of 57.27%. Let's try other skin lesions such as measles. So here we search a measles from the internet. Then submit for prediction. So it shows that it is monkeypox negative, but the prediction is measles with a confidence of 41.91%. So here is the Grad-Cam Here's the Explore tab. So here's the Explore tab. So there's a tab on how to use the app. What do the colors in GradCam heatmap mean? And disclaimers. And details about the application and the developer. And that would be all. Thank you.